So welcome everyone. Looks like we've got about 11 people minus the two Splunkers. We've got about 9 folks from the user group. I know the time difference did kind of get some folks a little challenged, but I'm glad that you are able to make it. The subject that Tony asked me to present on is CVE 2020-1350 or SIGRed. Um, I had was the author of a blog post, and I think I got some traction on the LinkedIn or social media circles, and he reached out and said, "Hey, this would be a perfect topic to kind of dive a little bit deeper into it, what detection looks like, et cetera." He thought it'd be a good use of everyone's time. So really excited to be invited here. We're going to go ahead and get started. We're going to run through introductions, myself and Brian. Going to go into an overview of the vulnerability itself. We're going to kind of talk about vulnerability data. We love data. We're Splunk. And then move into detection of such exploitation attempts. And then there's plenty of time for Q&A. I also want to identify that I would love for people to interrupt me and ask questions and engage in a dialogue. I'm happy if it's just a one-way conversation, but I think it'll be best for everyone if we are able to go back and forth. Do I see Tony joined us? Was he able to make it?
I am, but I'm in a car.
Welcome, Tony. We just kicked off. Before I get going, I do not intend to say anything about future capabilities inside of Splunk or whatever. And anything I do talk about the products made at time and date, right? I don't anticipate going into anything that relates to future roadmap items inside of Splunk or its software. But if I do, I'll try and identify that, and the most likely time that would happen is during any Q&A where we kind of go off. But just note, legal wants us to show the slide. I'm kind of letting you read it, and then I will move on. All right, I'm gonna introduce myself. Every Splunker loves and has a who am I slide. I didn't ask Brian to put one together, but I'll go through mine and I'll let him chime in and just kind of introduce himself. I have been a Splunker since 2019. I literally 2 weeks ago celebrated my 1-year anniversary. Before that, I spent 10 years working for the Department of Defense, specifically the Navy. During my time working as a Navy civilian and a couple years as a contractor in there, I did a number of different things. My last role was the DCO manager for the Navy's largest UIC, largest command. It's almost entirely civilian. Other interesting jobs is a risk management framework, security control assessor, and validator as the Navy uses us. I was also at U.S. Fleet Cyber Command, Commander 10th Fleet. And if you look right over here, there's a little paddle. I was my going away present, and I was there during the time that Vice Admiral Gilday, who's now the Chief of Naval Operations, was the commander there. I was responsible for writing the task orders and execution orders to defend Navy networks. I also did a number of different roles, kind of my introduction to vulnerability management, or my introduction to security as a full-time role was through vulnerability management. Also plenty of experience as a system administrator, mostly a Windows guy, but I can hack a little bit at Linux. Also, I'm a CCNA security, but when you don't touch Cisco stuff for a while, you'll lose some of the command line stuff. And I also spent some time as an application developer. I'm not that old, as you can tell by looking at my face, but my first programming language I did as a full-time job was Delphi 5, so Turbo Pascal, pretty old language. I also happen to be a Navy reservist. I commissioned this past January, my birthday. I'm an Ensign 01, so if I shrug, that's kind of what ensigns do because we don't know anything. Also want to highlight on a personal side, I'm a pretty boring guy. All of those things are true except that predictable and safe and secure job. I joined Splunk, so out of that federal service. And I'm also proud to announce as of 3 weeks ago, I finally hit diamond rank in Rocket League in standard threes. Brian, do you want to take a second and introduce yourself?
Sure, Brian Pluta. I've been to several of the local user groups when we could actually meet in person. I am actually a local Splunk resource in the Omaha area. I have kind of a background, kind of like Drew, where I spent a lot of it within DoD, went to the commercial sector for about 4.5 years before I joined Splunk. I've been with Splunk for almost a year and a half now, I think. And primarily cover DoD customers still, but happy to help anybody who's got questions in the larger Splunk family.
Thanks, Brian. Also want to call attention to the fact that he is probably about 1 billion times better of a Splunker than I am, especially when it comes to advanced architecture or other questions around the mechanics of administering and architecting Splunk. I am a user and a security practitioner. My skill set is not in like, hey, how are you going to deploy an index cluster and search head cluster with enterprise security? I'd love to talk to you about that, but not my skill set. But those questions are welcome, and we can do our best to answer them here during our time. Moving on, I want to talk about what CVE 2020-1350 is. And I'm just going to go ahead and start by citing the checkpoint researcher. I'm not even going to pronounce, try to attempt to pronounce their name. I would butcher it, I'm sure. But it's important to understand that it's a wormable critical vulnerability that affects Windows DNS servers all the way going back to 2003. If you're still running 2003, I'm sorry. And it can be triggered by something as simple as a DNS response. Because of the way DNS works inside of Windows, it's that service is running as an elevated privileges system, in fact. And then if exploited successfully, which is very easy without the patch being in place, the attacker is effectively granted domain administrator rights, depending on the architecture of your DNS infrastructure. And effectively, that compromises your entire that's the ball game, folks. So CVE 2020-1350, also known as SIGRed. I actually am not a huge fan of vulnerability branding, but SIGRed is a little bit easier to say, so I'll probably go use it from here on out. But what I want you to take away is it's bad. It's really, really bad. It's probably one of the worst vulnerabilities I've seen in a couple of years, just because of a few things that we're going to get into here. Why? From a quantitative perspective, it's a CVSS base score of 10.0. So the worst it gets cannot possibly get higher than 10. It does not go to 11. From a qualitative perspective, it affects DNS servers on Windows. So when you think about this, why does Windows matter here, right? Think about all the ISC bind vulnerabilities that you're going to see coming out if you follow like the NVD or ExploitDB or any of the security lists out there. It's important to note that every single Active Directory forest, which is the biggest grouping container of Active Directory and authentication inside of a Windows environment for those who are maybe not Windows administrators, they're all running DNS. It's also remotely exploitable. As I was kind of preparing for our talk here today, I actually went on to Shodan and I looked, and I found some searches, and there are 136 open as in no authentication, remotely accessible on port 445 domain controllers running 2008 or higher inside of Shodan's repository. That's terrifying to me. I would hope no one would do that. I'm guessing no small number of those are honeypots, but it's important to understand that if for some reason you have your Active Directory domain controllers running DNS exposed to the internet, it's a click of a button. It's also non-authenticated, which I think is a critical thing. This does not have to be something where you have to have logged in or have valid credentials. It's, again, non-authenticated. And again, it's running on almost every domain controller or DC in the world. Folks like proof. It's right there on Microsoft's website. You can read the text here, and I provide a link, and the slides will be available following our time here together. But effectively, you have to leverage DNS to make Active Directory services or domain services, sorry, AD, DDS, or just AD work. Since 2008, it had Forest functional level has required DNS. It's pre-2008 some stuff, but effectively everything is supported now. DNS is, you got to have it. When you dig into integrating ADS into an existing DNS infrastructure, there's more proof. The first thing that you do is you install the DNS server on every domain controller in the forest. All right, so you're talking about fault tolerance, good design, disaster recovery, high availability, scalability, et cetera. Right, it goes into describe how we run DNS inside of our environments. But you'll note I said almost every domain controller. Yes, almost. Someone out there, and if it was one of you, I would love to hear about it. Someone took Brad here seriously. It is theoretically and technically possible, according to the standards promulgated by Microsoft, to run Active Directory without a Microsoft DNS server in the mix. I don't know anyone that has done that. I would love to talk to someone who has done that, and I would more specifically love to know why they chose to do that, just because of how utterly complex it would be to do that and how you lose features out of the Active Directory integrated DNS. So So hopefully this wasn't you, but if it was, this vulnerability, I guess, doesn't apply to you because you're not running DNS. But effectively, a CVSS 10.0 vulnerability that affects every single Active Directory environment in the world is a pretty big deal. Moving on, let's dig into vulnerability data. And I say that vulnerability data is my favorite subject. I kind of cut my teeth as a security practitioner, being a vulnerability manager. Um, I actually got to do that before I had the opportunity to leverage Splunk to do that. I grew up on EI Retina or SCIVI, SECVI, if you're a DoD fan, or maybe a long time. That product stored its data in renamed Microsoft Access databases. So you can imagine how corrupt and how challenging it was to scan stuff. But I think vulnerability data is a really important thing for folks to talk about. Being able to have a robust scan, patch scan methodology is possibly one of the most important, like basic things that we can do it to support our environments. I know many of you aren't going to be DoD employees and working in commercial sectors, and I have a number of friends inside the space, commercial space. I'm great friends with a security architect at a healthcare provider, and he's explaining to me that like he has to get approval from some pretty high up people inside their organization, have a maintenance window to patch their Microsoft stuff, and it just blows me away that folks don't take this stuff seriously. This is the basics, right? You can buy all the fancy firewalls and security appliances. You can buy all the Splunk and log all the things, but unless you get the basics right, where we're talking about managing our vulnerabilities, understanding what our configuration posture looks like, and then assessing against that, like those are the key things, and they're unfortunately probably one of the most low volume, high value, and boring data sources out there. Like, I can't stress this enough. Like, vulnerability scans aren't that chatty. I mean, they can be if you've got hundreds of thousands of endpoints and you're running scans every day or something like that. But the data in there is so rich, but it's really, really boring. Who wants to go look at a table of data inside of Splunk that says this host has this vulnerability on it? I'm probably the only person I have ever met that wants to do that. I think it's fascinating. I also think that there's some great things inside of in vulnerability data that helps you prioritize that. But specifically as it applies to Splunk, uh, probably the two primary ways we see vulnerability data come into Splunk are going to be through Tenable's Nessus scanner, and that's going to be via Tenable.sc or Tenable.io. SC is rebranded Security Center, and IO is their cloud-based solution. Effectively same technology, but a little bit different monetization schemes by Tenable. And if any of you are working for the DoD, this is the Assured Compliance Assessment Solution, or ACAS. Qualys is probably the other second one, and maybe somebody out there is using one of you is using a different product. But again, that data can probably come into Splunk. I will say vulnerability data is a little complicated when we talk about Splunk because it's not necessarily time series, right? A vulnerability, especially when we're talking about Nessus and the plugins before the latest revisions, where we moved from a Splunk TA and Splunk add-on to a Tenable TA and a Tenable add-on. It was kind of a point in time that made its way into a time series structure of Splunk, and writing queries and deduping everything was a little bit complicated. Now it's there in the way that the API polls is pretty robust. Um, from a data model and scalability perspective, we have one. It has a catchy name. It's called vulnerabilities. Provided the latest version of the common information model link there for you. And there are two key fields used inside the SPL that we generated to check whether or not these vulnerabilities existed for SIGRed inside of the environment. Thing I want to point out on the common information model is for vulnerability specifically, that data model is one of the fields, and I actually literally just yesterday provided some feedback inside of the company on this, that we're missing a key field. When you look at Qualys, when you look at Nessus, you look at Exploit DB, or wherever you're getting your vulnerability data from, the vendors all provide a flag. Is this exploitable? Yes, no. I was at a talk with a kind of a practitioners group, if you will. I'm near Seattle, and unfortunately, it's now defunct, but it was one of the longest running security groups in the Pacific Northwest. We had this really fascinating talk one time. It was all around vulnerability management. Again, as I said, one of my most exciting topics, and it was interesting. The security researcher, I think his name was Michael Reitman. I think he works at Kenna Security now, regardless, his point was we spent a lot of time patching, scanning, and patching again, and targeting non-exploitable vulnerabilities. We should patch those. But when we start thinking about emergency things, hey, I need to get authorization to take my business critical or mission critical system down right now because of all these other things, like we should be able to go and say, hey, is this or is this not exploitable? In this case, the data can come into Splunk, but it's not a part of the baseline common information model data model. And hopefully they will add that in the next revision. But you definitely probably came here to hear a little bit about SPL. And this is I copy and paste it with a little, less pizzazz as we have in the blog post. This isn't that challenging, nor is it very interesting. It's certainly not novel. Here, we're using a tstats command. We're pulling it from the vulnerabilities data model inside the vulnerabilities data set, and then you can see that I actually brought forward a bad boo-boo from a prior post I used for inspiration on how we would detect that. You can see CVE equals star and MSKB equals star. Probably not the most effective tstats search in the world because we're bringing back more than we need and then filtering from there. But some of your data sources may not have those, and so filtering on that can be beneficial. But yeah, I'd probably move the search, some of that second search in the pipeline there to up into the tstats, and then simply renaming that and then tabling it out as you see fit. Again, not challenging and certainly not novel. But the thing I thought would be interesting and maybe of value to the folks here for the user group was talking a little bit about tstats. In the orange box at the bottom of the screen, we have a kind of I want to talk through how you build a tstats function. When I came on before we started with the talk today, I think Brian was talking to someone about some workshops, and one of the most interesting things to come out of the workshops that Splunk security practitioners, as well as folks like Brian, present on, we have one that's called creating correlation searches inside of enterprise security. It's a super fascinating workshop, and it actually, if you're doing it service and going through all the content in that workshop, it's an 8-hour workshop. Sometimes people muscle through and do it in a single day, but usually it's broken over 2 4-day sessions. Almost the first 4 hours of that session have nothing to do with enterprise security or correlation searches. It is all talking about tstats, data models, the common information model, and how they all come together to be able to help you run your searches at scale, and making sure that you're getting your data back as quick as possible so that you're not skipping searches, you're not missing data, especially when you're looking at using this for not just for like a spawn time and a report to an executive, but actively defending your mission or business network. So kind of walking left to right from a tstats starts with the pipe. And then the first thing you do is bring in a stats function. So your count, your averages, your distinct counts, your min, max, standard deviation, whatever, right? Your statistical function from. And in this particular case, and probably one of the most common ways to run this is going to be doing a from data model in the syntax, and then setting that equal to. And this is where so many people who are like really, 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 really close to getting a great tstats search don't get it quite right. I think our docs are clear on this, but it can be complicated, and this is an example of where it can be complicated. After from the data model, it's not just the data model. You want to use the data model and the data set. Sometimes data models are going to have one data set, sometimes they're going to have many. So specifying that is really critical. It's also important, and then when you're using a where clause, right? So you want to filter on that data set for some way. That the follow-on is the data set dot field name. And if you go read the docs on tstats, you'll see sometimes that the different field names or the data sets and the way they're named and the way you're searching, you don't require that dot notation for you SQL admins out there, right? There's also like when you're writing some SQL, sometimes you don't have to use your dot notation to talk about index and tables and all that stuff. But sometimes it is. I would just say as a best practice as you're getting used to writing tstats, if you're new to it, is using this dataset dot field name. And then when your field names have weird characters in them or spaces or other stuff, it maybe will get a little more complicated. And good luck figuring out what the quotes are. I still struggle with that today. But the takeaway here is data model from data model equal data model dot data set, and then the where is the data set dot the field name. It's complicated in this example because the data model and the data set are named the same. Vulnerabilities, vulnerabilities. But vulnerabilities, and you could create a new data set, extend that data model coming out of the SIM and saying exploitable vulnerabilities or whatever you want to name that data set, right? And then using that data set name when you're filtering in your where clause, etc. I'm going to pause for any questions because I think this may be one of the most interesting or possibly novel concepts for folks here at the user group. And I love taking breaks like this to take a drink. I see a question from Trevor. What workshop name was that? That was the creating correlation searches inside of enterprise security. At the end, I've got my contact information, and I'm sure Brian, I think, can share his in chat as well to talk, and we would be happy to talk to you about see how we can get that workshop run for you or for other folks. I think it's again, on that workshop, I delivered it to an aerospace defense customer of ours. And the best feedback I received, and I didn't create the workshop, I just gave it. The feedback from this guy, as soon as we wrapped up the first 4 hours, he said, in the last 4 hours, I have learned more than I have in almost 3 years of using the product at my full-time job. And I was like, whoa, that's compelling. And to be truthfully, I was learning things inside the workshop myself. I'm like, I didn't think I realized that. So,
Hey, Drew, I don't know if it's an official workshop, but if you guys work with your account team, that first 4 hours, I know within the DoD team, they delivered on their own. And it's just a T-stat, it's a T-stats and summary indexing workshop. So it's basically, how do you make Splunk go way faster using index summary and data model acceleration and those types of things. So if you're interested in those types of things, like I said, I don't know if it's an official one, but it's floating around there, and you can get it if you're really interested.
Yeah, and I also I never delivered the back 4 hours. We just kind of ran out of time, and they had some stuff come up the next day, so that was still incredibly valuable. So I think that they're essentially using the same content. One just doesn't go into the enterprise security portion of that workshop. So great feedback, Brian. And yeah, again, every customer that has gone is like, this is the best thing that we've had. When we start going from, hey, we have Splunk, how do we even use it, to how do we make the most use out of it and make it run as fast as possible. Moving on into detecting exploitation attempts, and we're going to use two different technologies here, Splunk Stream and ZEEK. But before we get into those specific technologies, I want to kind of go over what exploitation looks like. Again, I'm still using Checkpoint's original research to kind of to frame the discussion and introduce some of the concepts. Kind of the takeaway here with SIGRed is it's all about large requests and large responses. And so here, again, putting my hand up and being open and transparent here, I don't think I knew what a SIG record was in DNS until this vulnerability came out. I've worked with DNS, I've managed DNS just in my day-to-day. I've never really had to use them. And by the time we started really taking DMARC and SPF seriously around my roles, I had kind of moved out of that DNS role. So maybe just an immaturity on my perspective, but these queries, and I also run some. I'll get into this in a second. I run Stream at home, or have in the past, and I think in 6 months look back of data, and granted my home network, I don't think I had a single query for SIG. So very abnormal. So hopefully it would stand out in your noise. But the takeaway is we're looking for very large DNS requests and responses as part of the detection here, or what it would look like to exploit when you're looking at the pure wire data inside of something like Wireshark. For those of you who are not familiar with Splunk Stream, going into what it is, it's a wire data collection and analysis tool. It supports with deep capability over 30 different commercial protocols. And we're talking like IP, UDP, TCP, ICMP, GRE, and a number of other different ones. And again, that's a very rich capability. It also detects the usage of other I'll say sub protocols or other protocols for 300 plus, where you can start identifying, hey, like what maybe Tor traffic looks like, or what even encrypted sessions, right? Because you could just analyze, and sometimes even encrypted traffic, you can look at based on variability and key indicators inside those communications. What and give you a pretty good indication of what that traffic is. Stream is typically installed on a asset that is off of a span or a monitoring port, right? For you Cisco folks out there, right? When you set up a monitor session, a span port off a switch or off a physical tap, right? So maybe you have an optical tap between your firewall or whatever, right? So people, there's literally completely transparent versus possibly getting into issues in one of the management or data planes of your switch infrastructure. And Stream can also be used to read, parse, and ingest PCAP that was maybe captured outside of the Splunk ecosystem on a standalone laptop. Maybe you were doing some troubleshooting. So it's a great way to help visualize, gather that information, doing any number of different techniques. Stream also supports mapping into the common information model, like all good apps and TA should. I will just again throw my hand up and actually identify that part of the query for this detection is not mapped into a proper SIM field. So we always, even Splunk, have our own work to do around making sure that our apps and TAs are always synced up to SIM. I know we're as a company investing many resources and many people into making sure that we solve that GDI problem and give you the first class experience that you need. And I'll say that when I've consulted with customers, like, "Hey, tell me about Splunk Stream," they're like, "Hey, I've got this great like net witness peak cap solution. All these things. I've got like just this amazing architecture. Where does Splunk Stream fit into that?" It may and it can, and I would definitely consider looking at bringing that net flow and that PCAP data into Splunk in a way, but I probably wouldn't do it from Stream, right? Just because this is it's a purpose-built tool, but it's not going to have that full suite of capabilities. However, it is a great solution for the vast majority of customers I come in contact with because they don't have anything near that comprehensive. So if they don't have that purpose-built packet capture architecture and they want to get one started quickly, totally recommend it. In fact, when I was a customer before I was a Splunker, we were running into an incident handling process. There was a beacon that we could not identify. So, right, we had an upstream cybersecurity service provider saying, "Hey, we see something coming out of your network, and it's been coming here." And we could not find it. And so I was like, "Hey," I got through the emergency change management process. Said, "I just need Splunk is with enterprise security is my SIM. I literally need this data source." And we were able to get a monitoring port stood up, fed stream into it, and able to then identify very quickly the source of that particular host because, again, the person providing that tipper upstream couldn't see south of the firewall. Justin asks, what kind of data ingest rate does Splunk Stream require? It's going to wild just enormously based on that. But what's really cool is it's not full PCAP. So it's not ingesting, like if you think of like the traffic stream being, hey, like this was a 10 gigabyte network session, it's going to take 10 gigabytes of ingest into Splunk. That's not true. There's some calculators and some estimates inside the docs. But what's also really interesting is when you install Stream into the environment, you can turn on just the analytics portion of it so that you're not ingesting the data, so you can understand and target and say, "Hey, I'm going to run this for 4 weeks or 2 weeks, however you want," and say, "These are all of the different streams I want. Here are all the different analytics I want, all the capabilities," and then it'll build that over time. It'll say, "Hey, this is how much it is," so that if you do decide to go forward, you can buy the appropriate license size, or maybe move into ingest-based pricing if you haven't heard about that, which is super exciting. Brian adds that it's like ZEEK or Bro, if you're familiar with that, and we're actually going to talk about that and some of the comparisons here in just a few moments. So how do you use Splunk Stream? Very actually simply here, source equals stream :DNS and the source type. They're one and the same. You can, and you dig into the docs and Stream, because when you think about DNS is a protocol like that is above in the stack, right? Something like IP or TCP, UDP, right? Like and UDP for most DNS traffic. So you may be able to get to the same data the same way, but the way the TAs and the app works, if you have a decoder like the DNS source type, you would want to use that because it's going to have the best extraction and get after the information you want. From a data kind of structure and ingest perspective, Stream feeds in JSON to Splunk. I like JSON quite a bit. I also like our SOAR capability, Phantom. Everything it does sends in and out is in JSON. I think JSON is like one of the best data structures out there. JSON and Splunk from a pros and cons perspective, I think on a pros, very pretty colors. Love the colors, the red, the blues, different color blues, some purple in there. And it's got some really solid field extraction on the parent level elements, right? So like bytes in, bytes out, all this stuff. It does a great job. You can see the flow ID or like you get some really great top level stuff that's just no questions asked. On the other hand, when you start getting into nested lists and dictionaries inside of JSON, it can get kind of messy and kind of complicated. And so that's one of the things that I would love for us to kind of like provide a little more capability to our customers who maybe don't like messing with SPath so much. Speaking about SPath, that's part of how we use the initial detection capability for SIGRed. Again, nothing really, I will say, complicated or new or novel about this detection. Again, you want to start by scoping your data, right? When we're talking about performance searches, get it to wherever your stream data is going. Are going to be using that stream DNS source type. And we're specifically looking for the response message type. I mentioned before that there's a field inside of the SIM that is not there for network traffic and the maps into to stream inside the network resolutions data model. And that's the query type that it's there, but it's the connective tissue between stream and SIM isn't quite robust we want. And effectively, this SPath query helps pull it out so this is a little bit more searchable. So we're looking for either SIG query types or key query types. And when you dig into the write-up on Checkpoint, it could explain why, but I'd say the vast majority of people are going to be, from a proof of concept code perspective, effectively going to be using SIG. Also going to be looking at bytes out, because again, we're looking for that response as part of the best detection, and we're looking over a specific bytes out. I want to highlight a caveat here. So the original author of some of these detections, Shannon Davis, one of our Splunkers that a very similar role to Brian that works out of Australia, we collaborated on some of this stuff, and through further discovery as he was testing some of his detections and making sure they were rock solid, he discovered that Windows-based stream deployments have a problem. So if you're a Windows admin, you might be familiar with this. The TCP window sizes in 2012 and higher can't necessarily be adjusted in the same way they used to be able to. So if you're running Stream, which is supported on Windows and is also supported on your Red Hat, your CentOS, etc., you're running on Windows, you may not actually see a bytes out that's at 65 or 64 kilobytes or higher. Just because of the way that window size works. If you just change this to like an 8,000 ish, you're going to pick it up. However, he did some additional work on the detection and made it so that essentially, regardless of where you're using stream in your architecture, Windows or Linux, the detection will work. It's a little bit more complicated. I'm not going to get into it, but it's available. He also committed it into enterprise security content update via our open source product or project for all of our security content. Even if you're not an enterprise security customer, enterprise security content update is available for you. You can use all of that capability. But like the button that says implement this search inside of Splunk Enterprise Security probably won't work for you. But getting that information into Splunk, using that content, and even any one of you are more than welcome to submit great detections and content into that and make this a community-driven approach, just like we do with our apps and TAs. So that was published 5 days ago. Any questions on Stream before I move into talking about ZEEK? Making sure Brian's not like blowing me up on Slack. Nope, we're good. All right, Zeke. I bet many of you have heard of it. Many of you haven't. It was formerly known as Bro. And to Brian's point earlier, Stream is a lot like Zeek. I will say Zeek is probably way more capable, but again, they're not the same thing. They provide many similar capabilities, especially when we talk about look at the different Zeek logs or Bro logs that are available there. I'll let you read your the Zeek author's description of Zeek. But effectively, it's a sensor. It observes network traffic, generates great logs, and you can shove those into a SIM. Personally, I unashamedly love Zeek. A number of problems I have, right, especially when you start talking about software that costs something and doesn't, from an open source perspective, let's go. Like, I'm all about that, and it's amazing at how well it does it at scale. I also really appreciate people who contribute to open source projects, and the way you do that in Zeek, or they're called packages. You develop a package, you can submit it. And there's actually a vendor, Corelight. I really like Corelight's stuff. They do some really cool work and integrations between Zeek, provide capability there, and then they also work very well with Splunk and side by side with many of our products. They actually developed a Zeke package for SIGRed detection, and I'm going to be walking through that here in a second. I provided the GitHub link to that if you're interested. But it's time for the cybersecurity minute, huge reminder section portion of the brief. Supply chain risk management, or SCRM, is pretty big deal, and many of you are going to be thinking about it. Hey, did I check my Cisco box to make sure that the serial numbers match? Did I have traceability from when it left the factory to, was it all provided, the right vendor? Like, was it secure top to bottom, tamper evident seals, all of that stuff? We think about that a lot, especially in our secure environments or maybe classified environments, right? Hey, I'm really interested in solving for making sure that my hardware is like above board. So not only is it like there's nothing it's been installed in it maliciously, but it's also not counterfeit, right? So we're not investing in counterfeit or bad or secondhand equipment when we paid top dollar for new stuff. Supplier chain risk management is about software too. I want to call attention to Mr. Andy Gill here. He did a great blog post on the day he trolled the internet and created an accidental research project around SIGRed. So what he did was published on his GitHub repository a repo that said CVE 2020 1350 proof of concept code. Every security vendor on the planet, as soon as something like this gets dropped, Splunk included, is like, do we have a response? Do we have a play here? Do we need to enable our customers to be successful in using our products or our solutions to defend against this like nascent, like hot off the presses vulnerability? Some of us are ambulance chasers, some of us aren't. But at the end of the day, professionals get stuff like this wrong all the time. Vulcan is an example of a company who literally, and you can see here, linked to Zephyrfish's repository here. Hey, proof of concept scripts are available. I don't want to sit here and point out like Vulcan as being alone. In fact, when I was developing the blog post I wrote, I was getting in the middle of this. I hit up Google, just like everybody else on the planet does on this. Hey, is somebody out there doing something with this? I've got, I opened up TweetDeck. I added a new search. I want to look for SIGRed or CVE this hashtags. What's going on? And I found Zephyrfish's repo. I found the code. I went onto my terminal and I started typing git clone. And I said, that's not safe. And so I opened the source. When you take a look at the source for that exploit, pretty simple. 10 lines. No, it's only 7 if you remove the white space there. All it does is curl, and it's effectively kind of a rickroll. That's not a proof of concept for anything. That's somebody doing something and playing a joke on the internet. But what if like that was somebody trying to do something malicious? So I'm just going to go ahead and say, be safe when you're using open source code, when you're trying to get ahead of a problem. vet your sources. I'm not saying open source is bad. I am not saying that you shouldn't make use of like the community ecosystem. And in Splunk, we love the community ecosystem. Just understand where you're getting your code from. In this case, we're getting our code from Corelight. I know the guys over at Corelight, and I'm comfortable looking at it. So if you've never looked inside of a Zeke package before, and this is Ben Reardon at Corelight, he's on their security research team. This is the package he wrote. At the very top of the file here, you can see that he's created an enum there that corresponds to what kind of notice may come back. And if you scroll down through the code, there's some if-then statements saying, hey, there's 3 different sets of detections and what they're looking at for different packet sizes, different responses, and different all these signatures, right? And essentially it makes one of 2 determinations. Is like, is this a high confidence, meaning probably very low false positive rate? Hey, kick off the things. And there's also a potential like, hey, this might be a little sneaky or suspicious, bears further investigation, right? And then you can see that he assigned that notice type to the note field inside of the notice.log file that Zeke writes to. Over here on the right, you'll see a screenshot, just an example data set from a notice log file, and you can see a note field. You can also see, and don't tell anybody, but I reused the screenshot for my blog post talking about Zeke, using it to detect a different CVE. But effectively, this is the field that's going to come into a key field in the search, right? And so we're setting the note. So the note's going to begin with one of the 2. It's going to begin with effectively CVE underscore 2020 underscore 1350. And again, the Corelight package is pretty robust, does great things. But on our end, because we're taking all of the work that Zeke has done and that package has done for us, and essentially bubbling up an alert from those logs, either as a save search, as a report, as a dashboard element, or like an enterprise security notable event. Provided you're ingesting those Zeke logs, it's literally it's a 1-line script, right? We're looking at either of the source types that could potentially be Bro or Z data, and looking for that note field that is fed into category as part of that SIM process. I do want to call attention to the fact about those 2 log formats. The default in a Zeke, as of like at least 3 or 4 months ago, I haven't checked recently, I apologize if I'm wrong here. The default is tab separated value. You can also change one line in one configuration file to turn on JSON. I use JSON. I think it ingests more cleanly and is more forward-leaning from a Splunk perspective. And then obviously, just with any other SPL, you can do your transforming searches, and you can pull up your table, stats chart, whatever you want to look at it, however you want to look at it, you can do that. You're probably saying that was pretty boring. Like, that's like the least exciting SPL you've ever seen in your life. Especially when we were just looking at someone else's alerts. So don't worry, Shannon has you covered. He authored another detection and included in that same pull request, and it's around Zeke. So this gets back to the comment that Brian made, where there are different logs inside of Zeke all around the con.log, and there's another one, of course, I'm blanking on it right now, where effectively you're looking at those flows. It's not just an alerting mechanism. Hey, I see badness here, but it's also helping you understand what is coming in and out of the network, what the traffic looks like. And so you can then write detections against that, those connection logs. And what's great about the Zeke TA is that it maps directly without any problems into the different data models like network resolution. We can see here network resolution, and there's also network traffic and the all traffic. So there's some ins and outs about how we write enterprise security content. So if you do get interested in writing detections and committing them to the community repository, there's some macros in here like the security content summaries only, and you're looking at some other stuff where you have to figure it out. The Splunk security research team has some great blogs on how to get started if you're interested in doing this. But the kind of nuts and bolts here is that we're using T-stats to do this performantly at scale, and we're pulling from data models, and all of that information is there. So rather than using the Zeke package, where you maybe don't trust or not allowed to use open source code and you're not confident writing your own packages, you can just use that flow data. You can use that DNS data inside there to do the detection all inside of Splunk. So you have a couple different options there using ZEEK to detect SIGRed. And we have 12 minutes left, and I saved the rest of it for you guys to answer, guys and gals to answer or ask us a bunch of questions. It can be about SIGRed. It can not be about SIGRed, but yeah, open to anything. Brian, and I'll let you lead off if you want to add anything, if you think anything resonated with you.
Nope, I am much like you, running Zeke Stream, etc. at home off of a tap to get some visibility in terms of what's going on. Alternate use case, I actually used it. I haven't been able to figure it out why, but found that one of my kids' Kindles was producing somewhere in the neighborhood of like 7 gigs a day, even on days that they weren't using it. Never figured out exactly what the process was on a Kindle because it's kind of hard to do process exploration on a Kindle. But some cool use cases for products like that, especially this with resolution as well, or DNS.
Yeah, it reminds me. Unfortunately, my wife's at work right now. Otherwise, she'd probably kill me for telling the story. But right before I joined the company at Splunk, I was like, hey, I should probably make sure that all my skills for using Splunk are up to snuff. Right. I was in a management role. I still did plenty of hands-on keyboard stuff because I was down in the trenches with my team. But I went through kind of just a refresher to make sure I wasn't trying to bark up a tree and get a job somewhere where I was going to be embarrassed and not be able to help my customers. And so I went through Ryan Kovar and John Stoner, two of our principal security strategists at Splunk, their blog series, kind of threat hunting basics. And there's a blog on threat hunting inside of DNS data, and they recommend and they kind of walk you through setting up Stream for this. And I pulled in DNS data, and one of the things you want to that can indicate like command and control traffic is using Shannon entropy. Shannon entropy is like a formula that helps us identify the amount of kind of randomized characters in a text string, right? So if you calculate it, that string, you can see, hey, does this look kind of random? And so when you think about like a globally unique identifier or a universally unique identifier, it's all numbers, but it's jumbled, right? It doesn't make sense. Formula is not perfect, but it's a pretty good indicator. So I had installed Stream. I was monitoring the traffic, and my wife had just gotten back from having not a root canal, her wisdom teeth pulled out. And so she, all 4 had to be pulled out. They were impacted. It was a bad scene. She had literally about 2 hours before this all happened, she was lying in bed and she was on her phone. My wife is a hard worker and she was looking at her work email. And while I'm looking at this DNS dashboard, I've configured all this stuff. I see from her phone a query with like an extremely high, in terms of how ShannonHP works, extremely high like confidence that this is a random URL. I'm like, what is this? And when I dig into it, it was a DNS server that was set up like for phishing. So literally like a phishing attempt sent to my wife conveniently, and she had actually clicked on the link in the URL, like in the email, because again, like she's 2 hours after having major oral surgery done, probably not 100% ready to go. Fortunately, it was a company test, but she was definitely embarrassed to see that that had gotten past her. So you can do fun things at home in lab, and you can also detect phishing attempts with stuff like DNS. So it's kind of the sky's the limit. Anything else from the group? Would love to answer some questions or talk more about what you'd like to see from future presentations to help Tony out. Feel free to just type it in chat or come off mute if you're comfortable with that. Thanks for the kudos, Justin. I appreciate it.
I see Tony unfortunately dropped again as well, especially if it was in transit.
Yeah, doesn't surprise me. All right, well, I'll pause for about another 30 seconds, and if there's anything else, but I don't want to keep you unnecessarily, but I know sometimes it takes time to type out that question in a thoughtful manner, so don't want to rush anybody. All right. Unless there's any last nickels down, I just want to say thank you for allowing me to present to you today. I also just want to say thank you. This is the first time as a Splunker I've gotten to present to a user group or do something kind of in the community versus talking to customers about how we may help them solve a problem. I've done some webinars or whatever, but I've never been able to just talk to customers and share some knowledge. So it's been a privilege. I wish we could be doing this face to face, but for now it's virtual, and I hope to be back in the future. You can see my email and social media contact down there if you want to get more into this. We have recorded the presentation, and I do will make the slides available to Tony. I don't know if there is some if he sends out slides or whatever. So hopefully, if you something resonated with you, you can reference that or reach out to me or Brian. And I think he's at bpluta@splunk.com, and we'd love to talk more with you. But for now, thank you all for coming, and we'll talk again soon.